Today we're going to solve quadratic inequalities. So you might remember back in linear equations we solved inequalities, right? And they had to do with shading back and forth. And so same thing here. You remember open circle and closed circle and shading right and shading left on a number line. But here's our kind of step by step. I wrote it out for you. You're going to factor and quote solve each inequality as if it were an equality. In other words, we're going to get these like border points here of x equals 1 and x equals 2. And you look at the inequality to say, is that going to be an open circle or a closed circle? And it's hard to draw here, but it's going to be an open circle at -1 and an open circle at 2. That gives us what I call 3 chunks of areas on the number line. And you're going to test a number in each section to see if it works. So the easiest one to test is 0. And so if I go back to my original equation, does 0 plus 1 times 0 minus 2, is that positive? Is 1 times -2 bigger than 0? No. So you remember when you do test points, if it doesn't work, we don't shade. And what's nice about these is these either shade in between the dots or outside the dots. And so if I know that it doesn't work in between the dots, it's going to automatically work outside the dots. You could test other points to see, like I could test like a 5 and plug it in. Even just in my mind, I can see real quickly that that works and that -5, for example, works. Now, my inequality is represented on my graph, but I also have to write it as an answer. So my answer would be x is greater than 2 or x is less than -1. All those numbers that are shaded solve that inequality. Let's try another one. So here this is not factored for us, so I've got to move it over, I've got to factor it, and I'm going to get 2 border points of -2 and +2. And those are now going to be shaded in like full dots. So again, I can test any point, and it's going to alternate between working and not working, so I'm going to test the 0. I can test it in this factored equation, or I can test it in the original equation, whatever looks easier. It looks easier to me to test it in the original equation, and it works. So this solution is going to be in between, or it can represent it as in between 2 and -2. Okay. Moving on, so here I have x, and x plus 2 is greater than or equal to 0. This is going to give me closed circles at 0 and closed circles at -2. Now I can't test a 0, but I can test a -1. I'm going to test it in the original one. Does -1 squared plus 2 times -1, is that positive? Is 1 minus 2 positive? No, it's not. So this is going to shade out. And by the way, we're going to come up with a pattern that we're going to notice, and maybe you notice already. Let's see, this one is x is less than or equal to -2, and the or, by the way, is an important part of your answer. X is greater than or equal to 0. Do you see any patterns so far for when it was shaded in between versus when it was shaded out in each direction? I won't tell you, but we'll just kind of leave that open. Okay, the next row here steps it up a notch. Now it's a cubed. So t cubed minus 9t is less than or equal to 0. So this is like a whole different ball game because it's not quadratic, it's cubic. So when I factor this one, I get 3 spots to circle on my number line. 0, 3, and -3. And those are all closed circles. So this gives me 3 chunks to check. 3 chunks to check. Again, it's going to alternate between working, not working, working, not working. So really you can get away with just checking one number. So I'm going to check a 1 back in the beginning. Is 1 cubed less than or equal to 9 times 1? Yes. So that means that this chunk works, this first one doesn't work, works, doesn't work, and then works. You can double check, right? But it's always going to alternate between working and not working. And here's how this answer is represented. T is less than or equal to -3, or it's between 0 and 3. We do have a cubic one on the quiz, so that's why I put a few answers, a few of these problems here. So let's try another cubic one. Factor out a z, z squared plus 7z plus 10 is greater than 0. Z plus 5, z plus 2. So I'm going to have critical points at 0 at -5, and at -2. Again, it's going to alternate between working, not working, working, not working. So you might as well pick an easy number to plug in. I'm going to pick a 1. I'm going to plug it in. I could show this in the factored one. 1 times 1 plus 5 is 6. 1 plus 2 is 3. Is that positive? Yes. You don't even have to show your work even for the plugging in. So that means that this is going to work. It's going to alternate here and here. So if I want to represent that answer, it's between -5 and -2, -2, or greater than or equal to 0. And you have to have the written answer as well as the graph. Now you're getting the hang of it, so we'll just do one more real quick. X squared, it's a squared, minus x minus 12 is positive. So x minus 4, x plus 3, positive. So I'm going to have open circles now at 0, at 4, and at -3. Test points in one of the chunks, so I'm going to test a 1. I can test it in either the factored form or the original form. I'm going to do it in the factored form this time. 1 times -3 times 4, is that positive? No. So that means that chunk doesn't work, but every other chunk will. So if I want to represent that answer, it's between -3 is less than x is less than 0, or x is greater than 4. So it's a little bit different, I guess, but once you get the hang of it, then you'll be good, and you'll start to see the pattern, especially for the quadratic ones, of where to shade. Quadratic inequalities.